parts. A pair is two cards with the same number of faces. So this is a pair because they make a pair. Two of them. Now, a three of a kind is three cards with the same number on each face. So Jack, Jack, and Jack. Now, by the way, this is Jack of spades, Jack of diamonds, Jack of clubs. Okay? A standard deck of playing cards contains 52 cards. There are 4 suits. So, reminder, the suit is spades, hearts, clubs, and diamonds. That's the shape of the symbol. And each suit contains 13 cards, from an ace to a 2, 3, 4, 5, 6, 7, 8, all the way up to kings. That's 13 total cards. And the numbers are 2 through 10 and 3. Now, I know that sometimes you might not be allowed to play with playing cards, depending on your family beliefs. But if you're not and you're able to play them, go get a deck of cards, and there's a lot of math that can be done with that. Okay? 3 face cards are the jack, the queen, and the king. Calculate each of the following probabilities for randomly drawing 2 cards from the standard deck of playing cards. Well, one at a time with replacement. And by the way, what that means is if I'm drawing cards from a hand, and at some point after I've drawn my cards, I take that card out and I don't use it. Did you see the magic trick? Now I have 4. I didn't replace it. With replacement means I'm going to make sure that after I draw that card, I put it back in the pile. And that's important to note because by replacing the card back into the hand, I go from having my whole deck to having one less without replacement. With replacement, I get back to the whole deck again. So let's say, for example, you're going to randomly draw 2 cards from a standard deck of playing cards, one at a time with replacements. We're going to draw an ace first, and then we're going to draw a 10 second with replacement. So of the aces, there's ace of spades, ace of clubs, ace of, if I can find it in this time of the video, ace of diamonds, and ace of hearts. So that means that we have 4 different aces in the deck out of 52 total. So 4 out of 52. Oh, which, by the way, 4 out of 52 reduces to 1 out of 13, which also should make sense if you're looking at a full suit. So that's just the single shape. There's 13 cards in a suit, and one of them is an ace. So 1 out of 13. Multiply by the probability of getting a 10, it's the exact same. The fact that I drew a 10, there's only one 10 in the suit that is known as diamonds. There are 13 cards that are diamonds, so 1 out of 13. But if I look at the entire collection of all of the 10s in the deck, so 10 of clubs, 10 of hearts, and 10 of spades, there are 4 total 10s out of 52. So I could also say multiply by the fraction 4 out of 52, but that reduces to 1 out of 13. So then our mathematical answer is 1 times 1 and 13 times 13.
69 is approximately 0.005917.
Super low, less than 1% chance. Okay, what about an ace first, boom, and then a 10 second? What's the probability of that happening? Notice the word and versus the word or. The formula for or, go back to lesson 3, is that you take the probability of the first event. So there's 4 out of 52. There are 4 out of 52 cards that are aces. And then there are 4 out of 52 cards that are 10s. So 4 out of 52 plus 4 out of 52. But the chance that you're going to draw both an ace and a 10, this one, is 1 out of 169, or 16 out of 52 times 52. Hey Siri, what's 4 out of 52 plus 4 out of 52 minus 16 out of 52 squared?
4 divided by 52 plus 4 divided by 52 minus 16 divided by 52 squared is approximately 0.1479.
So 14.8%. There's a much, much higher likelihood, that's what probability is, it's the chance. There's a much higher likelihood that you're going to do this scenario of an ace in the first draw or a 10 in the second draw. 14% chance of that happening. We are going to continue talking about probability. Here's page 1 of this entire process right now for compound probability. See you in the next episode.